Welcome, everyone, to another episode of Training_Data. And today we're talking about one of our most favorite topics, which is SpaceNet. And in order to do it, we really brought in, one, a great guest, which we're really excited to have here, and then two, a training data veteran. So without further ado, let's get to the introductions. So first, I'd like to say thank you and a big warm welcome to Payam Banazadeh. He is the co-founder and CEO of Capella Space. Payam, thanks for joining us today from California.
It's super good to be here with you guys, and I'm excited about talking about SAR data, the best thing in the world.
And then to help us in this discussion about synthetic aperture radar data and how it could be incorporated into different challenges, we have, as some call him, or at least as I call him, the Count of Comet TS, or as some other people call him, the Colossus of cloud-free imagery analysis, the one, the only, Jacob Shermeyer. Welcome back to the show.
Thanks, Ryan. That's a great introduction. Happy to be here on the first podcast of 2020. For those keeping track at home, I have one podcast this year. Nick Weir has 0. Just remember that.
Challenge accepted.
Yes.
To Nick. And so let's get right into it. For those of you who have listened to the show in the past, we've talked a lot about different types of open source efforts. Clearly, our main effort has been focused on SpaceNet. And for those of you that perhaps aren't as familiar, that is a nonprofit LLC that we've been running with one of our newest partners, Capella Space. And our last 5 challenges, which date back all the way to our first in 2016, have all focused on using electro-optical data, specifically looking at foundational mapping features, building footprints and roads in those data. And the results over the course of these last 3 years have been impressive. But one of the things that's come out in some of the conversations, and is certainly big in the news right now, is that there are inherent limits to what can be done with electro-optical data, particularly in certain applications. And so as you're thinking about really the future of a machine learning workflow, what does it mean to deploy it in different use cases? The inevitable question comes in, well, what can you do with other data? And arguably one of the most interesting, timely, and in some cases most important data sets out there is synthetic aperture radar, or SAR. And historically, it's been something that is very hard to get access to. In many ways, it's very limited. And with Capella, particularly not just joining SpaceNet, but all the work that they have done, it really serves as an opportunity to democratize those data. And that's why, with today, focusing on what we're thinking about or planning for SpaceNet 6, and focusing our first ever challenge, not just on electro-optical, but on SAR, this is a really big step forward, I think, for the geospatial community, and it's certainly a big step forward for us on this. So kind of without further ado, let's get into it. So Jake, before we get into the challenge, or Payam, before we kind of talk about the company or where we see all this going, let's just do a brief overview. And Jake, just mind walking us through kind of what SAR data is, and then Payam, if you could just jump in and say, like, what are some of the benefits, and then that kind of rolls into kind of how you got this whole idea to start Capella. So Jake, lead us off first, and Payam, over to you.
Sure. So SAR is unique in that it's an active sensor. So with typical EO data, you have a passive sensor. You're just looking at how much light is bouncing off the surface. With SAR, however, you're actually shooting out a radio wave. It's bouncing off the surface and then returning to your sensor. And basically, that signal will tell you something about that surface. It might be flat, like water. You might not get much response back to the sensor, or you might get a large amount of response back if you have some texture or a hard angle. And that's really what SAR is great at. The most unique aspects of SAR are that it can penetrate clouds and work in any lighting scenario, including at nighttime. So this is really a fantastic nuance of SAR data, in the sense that it could be great for disaster response. Say you have a really cloudy scenario, you want to know what's happening on the ground. EO data simply will not work in a scenario like this. Furthermore, if you have a high revisit satellite, a constellation that Capella is planning to build, It's excellent in the sense that you are going to have a near constant collection of the Earth's surface, regardless of weather, which is awesome for time series analysis and seeing what's really happening on the ground. So that's definitely one of the reasons why we're stoked to have Payam in the studio here today to kind of walk us through what Capella's planning.
But and Payam, in our office, we have a bunch of rules, and obviously we always throw a couple in at the end of these podcasts. But one of them is, and this is something we've been saying since our founding, that geo is hard. And if geo is hard, then SAR, at least from my view, is even harder. And so, how did you decide to kind of focus on this market and take on arguably one of the most challenging but beneficial remote sensing data types?
Yeah, I think about that too often, and I question why I'm doing what I'm doing.
Just keep
but
doing
no, I
it,
mean,
please.
yeah, in all seriousness, it was triggered when the Malaysian MH370, or the flight that took off from Malaysia and was going to China, disappeared. This is back in 2014. And I remember I was watching CNN and other news outlets, and everyone was talking about this massive 777 plane with 280 plus passengers that couldn't be found. And as an aerospace trained engineer, my big question was, well, do we really not have enough assets in space orbiting Earth that can look down and trying to find some pieces of this plane immediately after crash and try to pinpoint and help the first responders? And that was the original question that I had, and that I kind of pulled that thread, and I knew of Digital Globe and Planet and Skybox at the time, and all these other companies that were doing Earth imaging satellites. But then that also led me to pull the thread even more, and found that, well, can't really see through clouds, can't really see at nighttime. There's a huge gap to be able to do persistent monitoring in a very reliable way, and especially in regions of cloudiness, essentially anywhere in the equatorial region, you're totally out of flux to be able to use these space assets to do any sort of monitoring. And then I came across SAR. To be completely candid and honest, I didn't know anything about SAR, and I hadn't even heard of SAR back in 2014. And so the first place I went to was obviously Wikipedia.
There you go.
And I was trying to figure out, how SAR works and what is it, and who owns some of these satellites, and how do they work. And I quickly realized it requires a lot of power, and the antenna needs to be really big because it's an active sensor. And it just, my engineering side of me sort of took over, and I just wanted to learn more about SAR and how the satellites work. And fast forward to now, building a SAR constellation is probably, and most definitely, not the best way of finding a missing plane. But what triggered us trying to think through the problems and finding the gaps was that incident. And from there on, the big problem that we identified was SAR seems to be very useful, seems to be a niche product, but it seems to be very useful. There is clearly a gap in capabilities in the market in providing persistent coverage of the entire globe from space. SAR seems to be the right data set and right sensor to allow that. And then the next step was, well, why is it that it doesn't exist? And the main reason was really, it's very complex. As a result of it being an active sensor, you do need to have a really large satellite. And in order to have a large satellite, got to spend a lot of money to build it and launch it. And so only a few countries have done that. There aren't that many SAR satellites. They're all government owned, and they were all built for either military purpose or very much so scientific purpose. So the data is not readily available out there. And then we started thinking creatively on, can we build a satellite that is much, much smaller and therefore much, much cheaper, that would then allow us to build a large constellation. And so as we got more comfortable with some of the answers that we initially came up with, and the answer was, yes, we think we could, then we started thinking about the business model, and well, hypothetically, if we did have a constellation of 30 plus satellites, and we could monitor anywhere on Earth persistently, all weather, all night, all the time, who actually would care about that, and what are the applications that would come out of that type of capability? And then we went into we switched from engineering mode to business mode, and we started answering all those questions, interviewing a bunch of customers, and trying to essentially build a business model around that. And so that was 3.5, almost 4 years ago. So that's sort of how we got started. And 4 years into it, we're pretty close to making the whole thing actually happen. In fact, 2020 is the year that we're gonna deploy the first batch of the constellation and go operational. And I'm obviously excited to talk more about that with you guys.
That's huge. And I think a couple of points you made, one that I really want to just to highlight, particularly for those who perhaps aren't as familiar, although everyone should be familiar with trying to order and access their own overhead satellite imagery. If you haven't tried that, particularly, Payam, you mentioned equatorial areas, there can sometimes be months-long collection gaps. Essentially, trying to leverage, your company's trying to leverage the few times where cloud cover breaks enough where you can have sufficient collect. If you're only doing a once-a-year survey of some type of land survey, that's probably okay, maybe not. But for anything else where timeliness is a component, and as goes without saying, most applications have an extremely time-intensive component, particularly in the domains that we focus on, that level of gap simply doesn't work. And so to kind of re-stress the importance of being able to collect in different weather conditions, it would be in this domain in particular, it'd be a game changer. And so what you're proposing certainly has a big impact. And I think the second point, just to highlight, just the importance of this year for you guys, if you haven't followed Capella, you've had a pretty, I would say, meteoric rise from your founding in 2016 to just in the last couple of years, raising a little over $80 million around there from some of the leading VCs around, including Data Collective and Spark. I mean, you guys have really made an impression on the Valley, and I think just to maybe get a little more detail, so you're going operational this year, but you actually have a couple launches planned for 2020, right?
Right. Yeah. So we launched our first satellite actually last December. Well, actually not December. Well, yeah, December of 2018. We launched our first satellite called Denali. That was our Pathfinder satellite. It was the first satellite we built as a company, and I don't really consider any company as a space company unless they put something in space and have been able to communicate and test things out. So that's when we became a real space company. We've been using that satellite to optimize the design and build all the ground infrastructure that's required for a fully operational constellation. So a few examples, we have a fully automated scheduler and tasking platform, which we've been extensively testing with the Denali satellite, and I'm sure we're going to get into it. But another challenge that people have been having in remote sensing is the reactivity is so slow, and so even if you have a constellation of 36, but it takes you 9 hours to request the task and receive some imagery, the urgency of using SAR is it's cloudy. I can't wait for the optical imagery to be provided, so I need to get a SAR image. And if it takes like 8-9 hours just for you to interact with that company and receive your imagery, that's also a bottleneck and a problem. So we've been using over the last year our Denali satellite to build all that ground infrastructure and automate it. That was our last year pretty much. And in 2020, we've got our first fully operational satellite that then we plan to provide imagery to customers going up in March on a SpaceX launch. It's called Sequoia. The name of our satellites are after U.S. national parks. So Sequoia is going up in March. We have 3 more going up beginning of the summer of this year, around June, July timeframe. and then we have another 3 going up um, in the latter part of this late summer of 2020. And so by the end of this year, we're going to have a constellation of 7 of our satellites up and operational, providing imagery to our customers. So 2020 is an important year for us, and essentially all the last 4 years of work that we've been putting into this company is going to come to fruition, um, and a lot more after that. But that's kind of how our timeline is. And a lot of these launches have been booked. As you mentioned, we raised more than $80 million of funding. Company is around 70 people now, and we're ramping up to be around 120 in about 6 months. So lots of hiring, and lots of good growth, and exciting times ahead for sure.
You know, and you mentioned something that I can't believe we haven't really gotten into this in the show, in either this season or last. But you know, we obviously focus so much on machine learning, but you highlighted, you know, the importance of the entire infrastructure system, from being able to process the task, to disseminate, to act, and then collect and distribute. You know, the central premise, or one of the central premises of incorporating an AI system into into remote sensing data collection, is because it gives you speed of analysis. Well, one of the reasons for that, right, is to then retask the system, or to initially task. And if you can't do that, you lose a lot of the inherent value. And so, what you're describing is certainly non-trivial, particularly at the scale in which you're describing, with that many satellites and
Yeah,
could test multiple
you know,
taskings.
one thing is, the problem of latency is an end-to-end problem, and a lot of the companies in our industry are so focused on just building a satellite, and they don't realize that the satellite obviously is an important part of this whole thing, but it's not the only part. The sensor is important. You got to make sure the sensor is producing high quality data, but then there's a whole suite of other things that need to be in place, and you need to really think about the problem from end to end. And you need to think about the user experience, what their requirements and problems are, and you might be able to optimize the satellite for that. But if all the other pieces that are on the ground is also not optimized for that, then you lose a lot of the capabilities that people actually care about. And so I have personally come to realize that building a space company, the satellite and the space part is only one portion of it, and a lot of the difficulty is actually on the ground, and how you get that much data down, how you do it quickly and efficiently, how you interact with the satellite, how you interact with the customers, how you do the processing. And quite honestly, that's been really, really challenging. And the amount of resources we've been putting and pouring into the non-space portion of this company has been quite a bit. Um, and so you're dead on how important that is.
And the ground part really brings us to some of the focus for today's conversation, which is, you know, on the open sourcing side and the follow-on SpaceNet challenge. You know, you mentioned how complex it is, how often people forget about it, and you alluded to this, that, you know, with your first Pathfinder satellite, you've been iteratively testing different aspects of the infrastructure. Well, similar with any type of advanced analytics system, you just don't simply deploy an app and hope for the best, right? You do iterative testing. And so as we now shift, kind of thinking about what's going to be open sourced in the coming weeks here, and then what will be used in the challenge, could you explain, both you, Payam, you and Jake, explain a little bit about the SAR collect that we'll be using, and kind of why you're collecting that, because that's really a part of a test to help you kind of move in your product development phase into having an advanced analytics system. So this is really sort of a test data set.
Yeah, let me maybe provide some input from at the high level, and then Jake,
Sure.
I would love to get your thoughts on this. So when we looked at the market back in 2016, we realized that, for lots of different reasons, one being SAR data is not very easily accessible. Two being SAR data is really, really expensive. If today you want to grab a SAR data from one of the leading SAR providers on the commercial side, you'll have to pay somewhere between $2,000 to $8,000 for one image. And so cost accessibility, availability, and then obviously ease of both requesting that file and then ease of use has really limited the user base for SAR. And those who are using it love it, and they can't get enough of it. They want more of it. But then the rest of us out here, a lot of us don't even know that this thing exists. And a lot of us know that it exists, but we've had a really hard time trying to get access to it. And so as a company, when we're looking at this problem of building a SAR constellation, we also want to make sure that there's a thriving community of users and developers that not only understand the capabilities and the usefulness of SAR, but they have some data available readily to be able to experiment, to play with, to build applications. And we need to build that community and user base because if that doesn't exist, then we're going to be building this capability, putting up this constellation, and we're still going to be limited to that very, very small user base that are there, but they aren't that big, and they're mostly in governments, and they're mostly sitting somewhere in the basements with some windowless rooms. And so we want to bring this out to the scientific community. We want to bring it out to the developer community, and we want to make sure they are trained appropriately and they know about how to essentially use SAR data. So before we even have launched our constellation, we've done some campaigns on flying our own sensor on multiple flights around, some in the U.S. and some in Europe, and we're starting to provide that data in sort of an open data license, so people can start playing with it and do some interesting challenges. And as we launch our constellation, we plan to do more of that. So we plan to make sure that there's always some capacity of our constellation dedicated to these communities, and it's a key pillar of our business model to build that community. And so that's sort of at a very high level. It's core for us to be supportive and make sure that people have SAR data available so they can start playing and putting that into their workflow and be able to experiment with how this would have some impact into what they're doing.
Yeah, and just to kind of continue on from Payam's thoughts there, the collect he's speaking about, and then the one that we're going to be using for SpaceNet 6 is one that's over Rotterdam. So this is an aerial collect, and when Capella came to us saying that they had this data set, we were naturally super excited just about the ability to open source some of this SAR data. SAR has been kind of SpaceNet's white whale, I would say, for the past 4 years now.
And
we've thought about it.
That makes Payam Captain Ahab?
I think so.
Or no, so. Ahab has the bad end. He's Ishmael.
Okay.
You're Ahab. Who's the guy that threw the spear?
I'm not up on my Moby Dick right now.
You keep talking. I'm going to look into it.
Okay.
No,
right.
I am listening while you're doing this.
Sure.
I need to Google that.
Right.
Shame on me for not knowing it. It's a great American novel. Anyways, please proceed.
But yeah, just to kind of continue on from that, I would say that, just to have sub-meter SAR data, I've been working on geo stuff for almost 15 years now. And when this is the first time I've actually seen half-meter SAR data visualized. So when another data scientist pulled it up, Daniel Hogan, he showed us, this collect. I was super excited. I mean, I've been in this industry that long, and I still haven't seen it. So that just kind of shows you how impactful a data set like this could be. And I think it's going to really produce a really interesting challenge and should open up this world to a great number of people who really haven't had the experience.
And I think the Rotterdam data set is, I think, the first data set actually that allows you to see what you would be able to do with a persistent collect. Because it's I believe, Jacob, correct me if I'm wrong, but it's every hour and a half or 2 hours over the same area. So you can see, what you will be able to detect from the change perspective if you could monitor the same area at a very high revisit that doesn't really exist today.
Yeah, that's right. Yeah, so we've got multiple overpasses over Rotterdam. I think it's taken over the course of 3 days, so you can see all kinds of stuff moving around. So it's a large port, right? The largest in Europe. So you see a lot of ships moving, you see cranes moving, trains, cars, obviously, but you can really start to see some of these interesting changes happening, which is a really cool aspect of this data set as well.
And so, and just as an aside, Jake, it was Staub.
Staub.
Stop. So
Okay.
Stop. You don't survive the last whale hunting expedition.
Okay.
Just
All right.
quick, just to manage your expectations.
I have until June at least.
Yeah,
so
you're good.
that's all right.
Just get through the
Get my will in
challenge.
order.
Yeah,
Yes.
there you go.
All right.
But in the context of the challenge, Payam, you've touched on this with talking about your company strategy on being very thoughtful in iterative development. This is a point that we have emphasized time and time again through our different projects. So this data set is certainly a resource that will extend far beyond anything we're going to do just in this particular data science challenge. But what's our first step in terms of trying to figure out the best utility or at least how the current state of the art models work on this? Walk us through a little bit about what we're thinking of from a challenge structure perspective.
Sure. Yeah, so, SpaceNet is really all about foundational mapping. So we're definitely going to return to that theme. That's something we're really dedicated to. We've made a lot of progress, I think. I mean, the scores that we've seen over the challenges have really risen consistently. And of course, that's all been with EO data. So adding this new modality is going to really test how robust computer vision algorithms are to new data and seeing how we can leverage it in new ways. So yeah, just kind of talk a little bit more about the data set and how we're planning to run this challenge. So we have the SAR collects that I and Payam have described. It's about 100 square kilometers we have of Rotterdam, so we've got a pretty significant area. Roughly 140,000 building footprints. So what's unique about these building footprints is they have the footprints themselves, but they also have height information associated with them. So this is another aspect where we're still toying around whether we want to do a height extraction component to this challenge. But at the very least, we're going to be doing, can you map all of the buildings in Rotterdam with SAR? The other aspect of this is it's going to be a data fusion challenge. So we're combining the SAR data with Worldview 2 data from Maxar, so that this has half-meter resolution as well. And the interesting aspect of this is really that for our training set, we're going to have a combination of the EO data from Maxar and the SAR data. But when we're scoring, we're only going to have the SAR data. And what we're hoping is people will use the EO data in some creative way to kind of transform or enhance this SAR data, and then apply some sort of pre-trained model to improve our SAR returns, and then hopefully we can see some sort of performance boost as a result. And the motivations for this are pretty clear. So you have an EO image and a SAR image concurrently from before a storm or from another area. A storm rolls in. Now you only have a SAR image. Could you still leverage the EO data in some intelligent fashion to really improve performance and increase your ability to pull out buildings or objects of interest?
And to be clear, right, that obviously we've been focused on a computer vision perspective, but that's just one way to approach SAR data, right? Both in looking ahead as well as how it's been analyzed historically, right?
Right. Yeah, and I mean, there's a ton of SAR expertise. I'm an EO guy myself, tried and true, so I'm still learning kind of the nuances of SAR. But the fact that it is an active sensor, the fact that it has complex data, we can track how long it takes a signal to bounce off the ground and return to the sensor, and kind of the angles of the signals that we're receiving. A lot of that can be really useful and valuable in the sense of pulling out how things change over time. And we can even detect minute height differences. So say there's an earthquake, you might see a shift in terrain or land cover as a result of this.
One thing that we're pretty excited at Capella about SAR is, as Jake mentioned, to use the complex part, the phase history, and to do some of the advanced techniques. One that's quite interesting to us is to do interferometry. And through interferometry or INSAR, you will be able to understand essentially deformations in the Z dimension to millimeter accuracy. And so people have been using SAR to detect tunnels, for example. As a tunnel is getting digged under the ground, that slight deformation on the top, um, as small as a few millimeters, you'll be able to pick that up if you were to do interferometry, putting essentially two images on top and extracting that space and looking at the difference. And so this has already been in use and demonstrated. An interesting project that some of our partners have been doing is using SAR imagery through INSAR techniques over London and look at the underground uh, tunnels for metro and looking at how the city has been deforming. And so you can then start doing some sort of predictions on where the risk might be. You could look at infrastructure. I know in government, in the defense and intelligence world, people have been using another version of this, the coherence. It's called coherence change detection, to see essentially tire tracks, right? So if you've got a big truck, you've got a big truck driving through, let's say, a muddy area or grassy area, the slight displacement will light up, and if you were to do an INSAR or CCD coherent change detection, and so those are things that it's not just about being able to see through clouds and at nighttime. Because you've got this active sensor, it's quite interesting to be able to dig in and use some of these advanced techniques and do things that you just can't even do or attempt doing with other types of sensors like optical.
Yeah, that's certainly a really cool aspect that we're excited about.
And I think Payam, you touched on this a little bit, as did you too, Jake. Putting these data out, and Payam, as you put out more data, it's really just a first step in building an ecosystem of developers around those types of challenges. As you mentioned earlier in your comments, a lot of this it's very specialized, and thus when you think about leveraging it in whatever type of analytic framework, it becomes really challenging, right? Because it's usually niche, or historically it was very niche or expert, and it required an expert, and then it required somebody to get specialized data. We're actually kind of flipping on it. You guys are flipping it on its head by putting these data out there, and now hopefully with challenges such as SpaceNet 6, we can start putting out a strong baseline for people to work on just as a first step. And I would be stunned. Let me inverse that. I think we'll see I think we'll see more excitement than what we've even seen with EO in the last 3 years, just to be perfectly blunt.
Yeah, I totally agree. There's been people clamoring for SAR data, I think, at the conferences we've spoke at, and just the groups we're tied in with.
Yeah, I think SAR has a bit of a marketing problem. It's got a marketing and PR problem, and part of the reason is if you look at a SAR image, it's not as pretty as an optical image, right? It's black and white. It's some artifacts that your eyes are not used to. If you think about it, your eyes have been trained over many, many thousands and millions of years on how to interpret the visible light, right? I mean, that's how you look through your eyes. But the framework of how you look at a SAR image needs to, you need to understand how the SAR image was collected. And when you start training yourself on, and you understand the physics behind it, and then you look at a SAR image, it actually becomes then quite clear for you. And then because, we're using machines these days to interpret and exploit the data, then it actually becomes less of an importance to be able to visually look at something and say, well, I can look at it better in an optical than a SAR, because if at the end of the day you've got machines telling you what it is you're looking at, and if you've been training the machines the right way, then it really doesn't matter if you've got that image from a SAR sensor or an optical sensor or any other sensor. And so the cool thing about SAR, and I think this is where we need to work on the marketing and the PR aspect of how SAR is being looked at, is it's got some really unique abilities and capabilities that other sensors don't. So if you get to a point where the machine doesn't see the difference, then SAR has got some interesting legs up compared to some other data sets.
Yeah, because the ultimate goal in this work is that we are finding answers to problems. In the case of SpaceNet, foundational mapping, but There's a variety of other applications, and so that's why we do this work. And so looking ahead, right? Walk us through the timeline, because there's actually a lot coming up here in very short order.
Yes. Yep. So we're going to start promoting SpaceNet very soon. SpaceNet 6, that is.
Technically, you're promoting it now, but sure.
Technically, yeah. But this comes out in a little bit.
All right.
So we're going to have our first announcements and the challenge launch, what we're planning for March time period. The challenge will run roughly about 6 to 8 weeks, which is our usual time period for SpaceNet challenges. And the cool aspect of this one is that after we announce the winners, some of the top participants will be invited to come and attend CVPR Earth Vision. So CVPR is computer vision pattern recognition. It's one of the top AI conferences in the world, and especially specifically in the U.S. And Earth Vision is geared towards overhead and geospatial imagery analysis. So we are the official challenge of Earth Vision, and as I said, the participants will be invited there to share some of their work, and SpaceNet will be helping to provide access for those participants.
And when is CVPR this year?
It's in mid-June, and it's in Seattle, Washington.
And tying it back to our earlier conversation with the Moby Dick piece.
Sure.
What does Seattle have? Ties to the book, the original Starbucks. Starbucks was Staub's friend. Remember that.
Okay.
All right. You're not doing great on this.
No.
Sorry.
Yeah.
It's fine. Can't win every day. So certainly that's on the challenge side. Payam, you've given us a lot of previews on the launch side. Is there anything else that you want to share on the Capella side that you're thinking about? I think what you guys are doing on this open data piece is going to be really cool to follow.
Yeah. No, I mean, the big thing for us this quarter and essentially in 2020 is making sure that the satellites get out of the door and crossing our fingers that launch don't get delayed. As you know, in this industry, launch delays happen quite often, so we're tracking those. And I'm optimistic that we'll be able to get these satellites out and into space. And then we're going to go through our commissioning phase and starting to put data out there and get into real business. So that's the front and center for us, and we're working around the clock to make that happen.
Well, that's awesome, and huge congrats to you and just how far and how fast you guys have come. Two not really important questions, but I'm going to ask them anyways. Do you have mission patches for your upcoming launch? If so, is there any way that we could have access to those?
We certainly do, and I will send some to you guys right after this call.
Excellent. We'll do a trade. We will send you a SpaceNet T-shirt in trade for a patch. That
sounds like a fair deal.
And then last question on my end. I love how your guys' naming conventions for your satellites. What's your favorite national park?
It's actually Sequoia. So I'm putting a lot of bank on this next satellite. Sequoia is my favorite one, and it's also the first one that's going to be operational. So definitely looking forward to that.
That's awesome. It's great karma. If I can, I don't think I can, but I will here. I just put in a vote for Joshua Tree. That's all I'm going to say.
I'm partial to Tetons.
Is Joshua Tree a national?
Oh my gosh, I don't.
Yeah,
man. I'm failing.
Look, what happened was the next batch of our satellites, or the constellation, is called Whitney, and so there's a huge argument in our office that Whitney is actually not a national park; it's a state park, and so we should go back and change the name. And our marketing department is like, oh my God, no, that's horrible because everyone knows about it now. And so I think it's gonna be a mixture of national parks and state parks and just beautiful places. Maybe at some point we'll diverge and do some other things, but we wanted to keep it as American as it gets, because this is obviously the first commercial SAR coming out of America, and so we're pretty proud and excited about that.
Well, your team certainly should be, and Payam, can't thank you enough for your team's support. Obviously, big shout out to also your team members, Andrew and Scott and Jason, for helping us on this. And thanks for making time today to come on the show. We really appreciate it.
Absolutely. Thanks for having me. We're very excited about this.
Hey, Jake,
us too.
Always a pleasure to have you on.
Yeah, I wish I could say the same.
Oh man. All right. With that said,
Wow.
it's been great. Stay tuned on all information related to both SpaceNet. You can find that on spacenet.ai, and then all information with Capella you can find at capellaspace.com. Thanks again to everyone, and we'll be talking soon.